Hello, good morning everyone. How are you? Okay, today we are going to discuss one very important chapter of inorganic chemistry, that is coordination compound. Yes, coordination compounds have great importance in all the field. Can anyone say in biological system the name of the coordination compound present in biological system? Yes. Okay. Chlorophyll. Chlorophyll is nothing but a complex or coordination compound of magnesium. Hemoglobin is a coordination compound of iron. Vitamin B12 is a coordination compound of cobalt. Like that, many coordination compounds are there. They have a great importance in all the field. We'll discuss afterwards. Today, in coordination compound, will mainly focus on introduction part. First, we'll learn what is actually coordination compounds. Let us see the definition. Coordination compounds are the compounds in which the central metal atom is linked to a number of anions. See, this is number. Anions is very important term. Anions or neutral molecules by coordinate bond. These two are very important term. Anions or neutral molecules and coordinate bonds. Coordination compounds are also called complex compounds or simply complexes. Let us discuss details about it. See, anions or neutral molecules. Anions or neutral molecules which can donate a pair of electrons are called what? Who can say? These are called Lewis base. We have learned in class 11. Now, in coordination chemistry, we will learn these anions or neutral molecules as ligands. What are called? Ligands. In organic chemistry, these any anion or neutral molecules which can donate a pair of electrons, we will learn as what? Nucleophile. So, new species are named as a different names are given in the different field of chemistry. Now let us understand what is the meaning of coordinate bonds. Yes. So, when we talk about bond, chemical bond, we have learned different type of chemical bond in class 11. You have learned mainly the electrovalent bond, covalent bond, you have learned. But what is coordinate bond? Coordinate bond always form between Lewis acid and Lewis base. So what are Lewis bases? Lewis bases are species which can donate a pair of electrons. Lewis acid can accept a pair of electrons. And coordinate bond always form between these two. Suppose if a species A has got one pair of electron and species B, suppose this is Lewis base and this is Lewis acid. And is an electron deficient species which can accept a pair of electron, then Lewis base can donate a pair of electron. And by that, one bond will form. Bond means what? This is a kind of force, kind of relationship. You are bonded to me. That is why now you are watching my class. You are attending my class. I am bonded to school. I am taking my class. Bonding. This is a relationship. Yes. Now, Here this is one relationship has been formed. That relationship is itself called coordinate bond. It is also called coordinate covalent bond or called dative bond. What is dative? Dative bond. Now this type of bond, coordinate bond, always present in complex chemistry. That is why they are called coordination compound. Yes. Okay. Let us discuss the example. Suppose here ammonia. We know ammonia is a neutral molecule. It has got one lone pair electrons. Do you know what is this? Boron trifluoride. It is a electron deficient species. Which one is Lewis base? This is Lewis base. This is what? Lewis acid. So it will donate a one pair of electron. So this is coordinate bond or dative bond. Now in case of coordination compounds, this bond always formed between what? Ligand and metal. This is ligands. I said ligands are what? This is a ligand. In details about the ligand, we will cover in another topic. This ligands are nothing but Lewis base. So always in coordination compound, one ligand, any ligand, donate one pair of electron to metal. Ligand metal bond, that is coordinate bond, always must be present in complex entity. That is why they are called coordination compound. Have you understood what is the meaning of coordinate bond? Okay. Now the branch of chemistry. See, the branch of chemistry in which we discuss about the only coordination compounds, their structures, properties, naming, bonding, in all aspects we discuss. That is what? Coordination chemistry. That is the introduction part of this. Okay. So what is called coordination compound we have learned. What is coordination chemistry? We have learned. Now one very important thing, why coordination compound? Here you see the next sentence, let us focus. Why coordination compounds are also called complex? Why coordination compounds are also called complex? Complex compound or complexes or complex salt, complex entity. The complex term, why do you say? Let us understand it. Why do you say the complex? Yes. To understand why coordination compounds are called complexes, we have to understand the difference between the simple salt, double salt and complex salt. So simple salt, we are well acquainted with the simple salt. One simple salt always formed from the one acid, one and base by neutralization reactions. Any example you can take, suppose potassium chloride, KCl. If we take, here is one cation, one anion is there. If we put any salt, here it is, suppose it will put in aqueous, that is water, the aqueous solution you will prepare, it will dissolve in water, then what will form? What? They get dissociated to their corresponding simple ions. One is cation, one is anion. And this can be very well detected by simple chemical test that in class 11 you carried out qualitative analysis, that is salt analysis. With the help of salt analysis we can very well identify the cation and anion present in a simple salt. Yes. Now this is a simple salt. Now two more terms. This is double salt and complex salt. What is the difference? Actually both double salt and complex salts are called addition compound or mixed compound, remember? So addition compound may be a double salt or maybe a complex salt. We can say complex salt or complex entity, coordination compounds. Yes. Okay, let us take the complex salt, or we will name it the complex salt. Now, what is addition compounds? So, addition compounds are obtained by mixing two stable compounds, making stable salt. For example, double salt. Let us take an example of double salt. Say for example, potassium, potassium sulfate, aluminium sulfate, 24 water. See, what is this? Potassium. Potassium, you know, fitly we can use it after say purification of water. So this potassium is an example of double salt. We can get it by mixing two stable salt, potassium sulfate and aluminium sulfate. Yes. Now when a double salt will mix in water, dissolve in water, what will happen? They get dissociated to their corresponding ions. Here we will get potassium ion, of course it is 2 potassium, plus sulfate will get SO4 2 minus, what will get aluminium will get Al3 plus. So these are the simple ions we get. When double salt dissolve in water, they also get dissociated to their corresponding ions, which can be detected, can be identified by the simple chemical test. If we carry out barium chloride test, we will get sulfate. If we carry out lead test, we can get the aluminium, like that. We can identify the simple ion by their what? Chemical test, simple chemical test. But in this case, since it is an addition compound, complex salt, complex entity, since it is addition compound, they are also obtained by mixing two stable salt, two stable compound. Let me give an example. Suppose double salt. Here, if we talk about the complex salt, suppose FeCl2, okay, ferrous cyanide plus potassium cyanide. When these two stable salt will be mixed, then we will get a compound sorry, this FeCl whole 4, yes, wait for FeCl6. See, for balancing I am putting here this 4. We are getting one salt. Why you are telling this is a salt? Because what? One cation is there, one anionic species is there. Alright. Once again I am telling, when I will mix two salt, to stable salt in a stoichiometric ratio, one fixed stoichiometric will be there, it is 1:4, then we are getting a salt. So what is the cationic species and anionic species here? Here it is K4. See, potassium is K plus 4 potassiums are there, means this must be the anion residual charge. The charge of anion must be FeCN whole 6 4 minus. See, this is 4 minus and 4 plus. Let me write here once again. This is a salt. You are telling this is a salt because you have one cation species, one anionic species is there. This 4 minus, therefore it must be 4. Yes. Any salt, one counter, against a counter cation, counter anion must be there. Like you see, magnesium chloride, if you write MgCl2, why this 2Cl? Because here it is 2 positive charge, so this is 2Cl minus must be there. Sodium chloride, Na plus Cl minus, cation is written first, then anion. Okay, similarly, these are simple. So similarly in complex also one cation, one anion. But what is the difference between simple, double and complex salt? In complex salt, one complex entity must be there. This complex entity may be cation, may be anion, and may be both. What I mean to say, the cation may be complex, the anion may be complex, or both may be complex. Now in this example, here you see the anionic species is complex entity. This is a complex species. Why this is a complex species now? Why do you say complex? Because when we dissolve this salt in water, it will never get dissociated to their simple ion. Simple ion is what here? Fe2 plus. It will never get dissociated to Fe2 plus. Here it is, will never get dissociated to the cyanide ion. This is complex. Have you understood? So, this is a one complex entity, and this is anionic. Complex entity may be cationic, may be anionic, and may be neutral. Let me show you. So, complex entity may be cationic, may be anionic, and may be neutral. Let me give you an example. Now, just now, whatever example I have given, this is the I have given. It is anionic. So, cationic. Suppose see, this is a cationic entity. Anionic entity, just now I have given example FeCN whole 6 4 minus. There are many. Neutral is a neutral. Now, how the complex entities or complex salt or coordination compounds are represented? Generally, the complex entity, this is complex entity, always it is kept inside the square bracket. This is the central metal atom, and this is ligand. This is called residual charge. The charge of it. All the terms once again we will learn. This is the only introduction. Why do you say complex? Why do you say it is a coordination compound? Similarly, anion and neutral. So, coordination compound, we say it is a coordination compound because of presence of coordinate bond or dative bond. Here you can say, in all the cases you can say coordinate bond between the cobalt and ammonia. Here it is iron and cyanide, nickel, carbon. You can say this is, suppose in this case I am showing you how to show this. Like this one I am showing. How to show the dative bond? Is a octahedral species depending on the secondary valency. That is, how many ligands are there attached to the central atom. The geometry is fixed, that you will learn in Warner's theory in the next class. See, these ligands are what? Ammonia, NH3, 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 NH3. See, this entirely how it is represented. These are the ligands, ammonia ligand, they are this arrowhead representing what? Each ammonia ligand is donating one pair of electrons. These are what? These all bonds are coordinate bond. These are central metal. These are coordinate bond. These are ligands. This is residual charge. So this is one coordination entity or complex entity. We say it is a complex. So basically today we have focused in introduction part only the definition of coordination compound. Why are they called coordination compound? And the coordination compound, why are they called complexes? Have you understood? Okay, we continue. The next in my next video classes we will learn about the Warner's theory. Okay, for today here only I have stopped. Thank you. Bye bye.